ICS2O, welcome, folks. Lesson 3.8 on selection. Selection, ifs, decisions, that's what we're talking about today. At least it's our first day of selections. We'll actually be spending a couple days on this. You can see I got Smart Notebook open. You don't have to use Smart Notebook if you don't want to. You could probably use your Google Docs or any word processing document that you want. There's going to be some pictures at the end, but those aren't going to be compulsory to have those in your notes. But notice that I do have Turing open, ready and waiting for me to type some code in to play with and explain the concepts that we're going to talk about. All right, so let's get at it. So we use the if structure to allow the computer to make decisions. This whole idea of sometimes we want one thing to happen and then sometimes another. The syntax is this, and notice that the font that I used here, straight from Turing, is Courier. If you want to make it look like Turing, you can use Courier. I'm going to copy and paste this into Turing so you can see what it looks like. Notice that the middle, I cut it right out. There it goes. The middle statements is whatever statements we want to have happen. So if condition, some condition that the computer will make decisions, then, and then these statements will occur, and it ends with end if, there, just like that. So this condition, whatever this is something. So for instance, if Mark is greater than or equal to 50, then put you passed, for instance. Now, of course, if I try and run this, it's going to say, what are you talking about? I don't know what Mark equals. So I'm going to make a little, and you don't have to necessarily be typing this out, but Mark integer, and then I'm going to put Mark equals 65. And so obviously this is going to be true because the condition is true. It should write out you passed. It should. And bam, there it is. But if I were to go back and change this to 45, it should do what? Well, this isn't true at all, right? It didn't put out you passed. It didn't execute this command at all. So that only works if that statement is true. Condition is either true or false. So whatever this is, Mark greater than or equal to 50, that's a condition, is either true or false. This idea of true or false is called a Boolean variable, and we'll talk about that again later. To finish off this page in the note, we had a couple of examples. I had that one. This one, if name equals furred, so there's my condition, name equaling the string furred, then it says put hello furred. So why don't I try that? Oh, not paste. Edit, undo. Control C for copy. Paste that in there just to see if it works. Right now it's not going to work because I don't have a variable called name, and it's a string. Right? So now that should work. But what's string equal to, or what's name equal to? Well, we don't know. So let's assign it something. Name equals dref. And so is it going to print out hello furred? No, because Mark is equal to dref. Or sorry, name is equal to dref. And in fact, nothing happened. It finished executing without doing anything because this statement wasn't true and the statement wasn't true. Okay, so there's a couple of examples. Hopefully you get them into your notes there. We use the following symbols to make comparisons. And this is mathy feeling to it. And it is mathy. That symbol is the greater than symbol. That symbol is the less than symbol. I want to show you a little trick to show you how I remember. That symbol there is the one that makes the G for greater than. It looks like greater than. That one is an L for less than. That's less than. And that's how I remember. That's how I know how to read that. When it's the two symbols next to, greater than or equal to, that's greater than or equal to, less than or equal to. If we wanted to compare whether it was just equal or not, it's just an equal sign. Remember that the colon equal is used to assign values to variables. So remember, when we were assigning values, like mark equals 45 and name equals dref, that was assignment. This single equal sign is a comparison. And then if I wanted it to be not equal to, I just write the word not in there. So let me show you how that works. So for instance, if not equal to Ferd, then put hello, not Ferd, but hello whomever. And see if that works now. It should. Hello whomever. There it is. So that worked. Dandy. Moving on. And remember, if I'm going too fast, you're pausing. Don't be afraid to ask about something you see. If you can pause and ask me right when you get to your questions, right? Because I'm right over there. You can probably look at me and wave. Just wave. There I am. We can make our decisions more complicated by using the keywords and or. So for instance, I'm going to type this example in. If mark is less than 0 or mark is greater than 100, then put invalid mark. So what does that code do? Well, notice if I had a mark that's equal to minus 200, and if I wanted to check and see whether it was a valid mark or not, if mark is less than 0 or mark is greater than 100, then put invalid mark. Now, it's still invalid. I haven't had a chance to change it or anything like that. But notice that this whole condition, this or this, as soon as one of these things is true, then it's going to write that statement out. So it wrote invalid mark because this one was true. And then it did this one still as well. So here's another example. If name equals Ferd and password OK, then welcome Ferd, proceed. Well, this is a little bit of a strange bit of code. I'm going to copy that out and play with it. So for this one to execute, both things have to be true. This has to be true, and this has to be true, which is a little bit of a weird look there. Notice that right now, name is not equal to dref, or Ferd, it's equal to dref. And so is this true? Well, it's going to give me an error. It says password OK has not been declared, so it doesn't know what password OK is. And notice password OK doesn't have any condition in there, but what we can do is we can make it a Boolean variable on its own. I'll show you what I mean. Boolean is actually a type of variable just like int or string, except for password OK can only be true or false. So I'll show you how that works. So for instance, it'll be some sort of password lookup program, but we're faking it a little bit here, aren't we? So password OK is equal to true. So name is Ferd, password OK, that's true, and then it should write welcome Ferd, proceed. Welcome Ferd, proceed. No, notice if I change one of them, so if I change password OK to false, Ferd has forgotten his password, then all it's doing is running this first code. It's not working there. Similarly, if I change this back to true, someone has got Ferd's password right, but the name isn't Ferd, that won't work either. Now this one worked because it wasn't Ferd, but this code here did not work. So this idea of a Boolean variable, pretty neat, that we don't actually have to be a condition. It's a condition kind of all on its own, which is pretty cool. So note in the example above, password OK is a Boolean variable. Somewhere else in the program, we would have seen the lines var password OK is a Boolean variable that declares the Boolean variable, and then later we would set it to be true or false, and then that becomes the condition. That's pretty cool. It's a little bit shorter and easier to read. It almost reads like English. If name equals Ferd and password OK, then proceed. Almost like English, not code, and that's a nice feature. Next, what's next? All right, and anything you see in these red lines there, you don't have to copy that down, but this might have been what is occurring to you out there in computer land is what happens if we wanted something to happen if the condition was false? So if name equals Ferd and password okay, you'd say, okay, proceed Ferd. But if it's not, we want to say, please enter your password again, or, user not found, or something like that. We want to have something else uh, happen. So the syntax is like this. So if condition, then we're going to execute these, else, and that's kind of sounds like English, but we use the else, execute these commands. And that's if this is false, then it'll execute these commands, and it still ends with an end if. So here's an example. And you can copy these examples or not. I guess that's up to you whether you want to copy your examples. This example, if name equals Ferd, put hello Ferd, else put hey, you aren't Ferd. So I'm going to try that. I don't know if you noticed this this kind of neat thing about first of all the indent button. I've told you about the indent button, but a nice feature is you can comment out a whole bunch of stuff at once just by hitting edit comment range, and then that comments that all out. If you want to uncomment it later, edit uncomment it will get rid of that. So I'm going to comment that range, and so just this is going to run. Okay, so if name equals Ferd, then hello Ferd, else put hey, you aren't Ferd. So first of all, is name equal to Ferd? No, name's not equal to Ferd, so which one's going to execute? This one here is going to execute. And I run that, and that's exactly what happens. Similarly, we could have if mark is greater than 50, then put you passed, else put you failed. And then that could be the command. And all these conditions in here we can do on numbers or on variables or whatever. I think I have one more example, and that's, could I say, if mark is greater than 50, you pass, but if mark is greater than 80, you got level 4, and maybe more than one condition? And the answer is absolutely yes. We can make a series of decisions using the if, then, else if. And notice that's not spelt right, but that's the key word in Turing. So here's an example. So if mark is less than 0 or mark is greater than 100, we're going to say invalid mark. Else if mark is less than 50, then you failed. Else put you passed. So that's like 3 possibilities: an invalid mark, or a mark is less than 50, you failed, or you passed. So I'm going to copy that into my Turing program just to show you that it works. I don't know, it puts these weird characters in here. And I'm going to hit my indent button to line it all up and run. Oh, mark is negative 200. So what's going to print out? Invalid mark. Yeah, invalid mark printed out. So let's see if I put this in whether this code works. What I'm doing here, by the way, is testing my own code to see if it works. And you got to run it a few times to see if it works. Yep, that looks like it worked. All right. I think that's all I wanted to say about ifs. Oh, this is a little bonus learning. We just and if you're not interested in this, you can shut this off and start the exercises. But we talked about flow charts. So this is a picture of an if statement. Here comes the program, and then the condition happens, the if happens, and executes certain things if the condition is true. If the condition is true, flow goes this way, commits, does these statements, and then returns back to the regular program. An if-then-else structure, program decision, an if statement of some sort. If it's true, it does these, and then goes back to the regular program. Or if it's false, this is an if-then-else structure. Then it does these statements and then goes into the regular program. This is a picture of our program using an ELF structure, an ELF structure, not an ELF structure, an if-else structure. And you don't have to get these into there. If you want to, there's lots of versions of this on the internet. All you'd have to put in is flowchart of if statement, and bam, it'll come up. Certainly you could copy and paste this one from the video, probably. Okay, now it is time for your selection exercises. So save up your note, remember, and have fun making Turing make decisions.